Then let's get started. Today we are going to talk about Scope 3, Category 4 and 9 up and downstream transportation. Now, who are we? I'm joined today again by Ruben Pelkmans, who is head of customer success for ClimateCamp. And Ruben is involved in corporate carbon footprint calculations and product carbon footprint calculations for a lot of our customers. So he is really near to the topics of calculations. So he will assist me in showing how we calculate transportation in ClimateCamp. And I am Maarten de Kroos. I am the marketing lead for ClimateCamp, and I'm going to take you through the main concepts of transportation. Now, what are we going to talk about today? I am going to give a short introduction to Scope 3, Category 4 and 9. I'll give some definitions and speak to the impact of transport emissions as a whole. And then we'll focus a bit on the GLEC framework, which we use as a basis for calculating transportation emissions. And then we'll move on to how to calculate Scope 3, Category 4 and 9. Afterwards, Ruben will give a demo of how ClimateCamp helps with these calculations, and we'll also have a Q&A at the end. Now, before I get started, I mentioned we have a Q&A at the end. In Microsoft Teams, on top or on the side, I'm not quite sure, you have a Q&A section and a chat. If you have any questions during the webinar, please paste them there, and then we will answer them at the end of the webinar. Now, let's get started. Now, today we're going to talk about up and downstream transportation and distribution, also known as Scope 3, Category 4 and 9. Now, I'm going to give a small nuance because, as you can see in all the Scope 3 categories, there is more than these categories for transportation. We also have business travel and employee commutes, but these we will not be covering in this webinar. We'll also mainly focus on transportation, not distribution, because it is mostly material for most of our customers and most companies we encounter. Now, up and downstream transportation and distribution. When we look at the definitions, there is something very important to notify here. Category 4, so upstream transportation and distribution, covers all the emissions from moving purchased goods from your Tier 1 suppliers, Tier 2 to Tier 1, towards the reporting organization. It includes all third-party transport and warehousing of purchased goods, but, and this is very important, it also includes customer deliveries paid for by the reporting customers, by the reporting company. Whereas Category 9, downstream transportation and distribution, covers all the emissions from moving and storing sold products from the reporting company's facility to the end customer, where the transport is not paid for or operated by the reporting company. This is an important distinction, which we will come back to later in this webinar as well. Now, why should we care about up and downstream transportation? I've taken the left visual from the GLEC framework introduction, which showcases all the emissions coming from transport, freight transport globally, which is now 4 billion metric tons of CO2 equivalent, and it will grow to 6 billion tons. And transport as a whole is even double that. Passenger transport is the same amount and even more emissions coming from freight transport. So transport emissions are expected to double by 2050. So it is a very important focus area for companies to calculate and reduce their emissions. On the right side, you can see a study by Transport and Environment, where you can see that for the different industries or different sectors related to emissions, that transport is one of the only ones that is still increasing or that is still taking up a larger portion of the emissions profile. Now, as I mentioned before, employee commute and business travel, these are also transportation and will focus primarily on passenger transport, which is more important for service companies. But today we're focusing on up and downstream transportation because for manufacturing companies, this is a very large part of their emissions. Obviously, the first place will always be purchased goods and services for manufacturing companies, but transportation plays a large role as well. And as I mentioned before, you can see it here when we look at EU emissions between 1990 and 2019. For almost all of the industries, it has gone downwards because we have dropped 24%. But transportation is one of the only ones that has increased its emissions profile or its emissions intensity. So it really matters that we calculate up and downstream transportation, and it matters that we find ways to reduce it. Now, before we move into how we are going to calculate it, it's very important we talk a bit about the GLEC framework. Now, the GLEC framework is the GHG protocol of logistics emissions, or is like the holy grail of transportation emissions calculation. It was developed by the Smart Freight Center, which was a collective of major transport and warehousing players. And what they did is created this framework which helps with transportation emissions calculations, especially for transport providers and logistics providers themselves, so the carriers, but also for shippers, such as the manufacturing companies or other companies that make use of these logistics providers to transport their goods from and to their organizations. Now, the GLEC Framework v 3.1, which was released earlier this year, fully incorporates ISO 14083, which is the standard for transportation emissions. Whereas GLEC is more the guideline and how to apply these transportation calculations, the ISO is the international standard. Now, it is important to know GLEC aligns with or takes into incorporation greenhouse gas protocol, science-based targets, and CDP. So if you disclose via CDP, if you have set science-based targets, or if you are using the greenhouse gas protocol to calculate your emissions, these are all aligned with the GLEC framework. Now, when we're talking about GLEC framework, there are certain concepts, certain ideas, certain definitions which are important to understand. The first being the transport chain and transport chain elements. Now, when a good moves from, let's say, purchased goods moves from your supplier to you, it will undertake different legs or transportation legs to reach you. For example, it will have road transport for the first mile, it will have road transport for the last mile, but here in this example, the main transportation method between these two is rail. But we also have to take into account the hubs where the container, for example, that is moved from the truck to the train and from the train to the truck again, also need to be taken into incorporation. Here we are talking about a transport chain element. So it is defined by a freight being carried by a single type of vehicle or transiting to a single hub. So one part is a road transport, one part is rail, one part is a hub, for example. The activity of a transport chain element is expressed in ton kilometers. And ton kilometers is the mass of the goods being transported multiplied by the distance traveled. This is the main way we are going to use or going to do transport calculations when using weight-based, transportation weight-based calculations. The second concept, which is really important to understand, is well-to-wake. So well-to-wake is how we account for emissions from transportation from raw material extraction, such as crude oil extraction, up until the point where fuel is transferred to the propeller or the combustion engine. Why is it called wake? Wake is relevant for air travel and sea travel. When we're talking about road transport, this concept is called well-to-wheel. As you can see here, well-to-wheel is divided into two main sections, being well-to-tank, which means the fuel is being extracted, it's being produced, and then stored and transported to a certain place where it can be distributed, let's say a gas station, for example. This is well-to-tank. And then the second part is tank to wake. Now, tank to wake is from the moment you pump your fuel at a certain location, you store it on board your vehicle, you convert the energy, and then you burn it in a combustion engine or you use it to power a propeller. Why is this important? Because it takes into account the entire life cycle of fuel consumption, which is very important for calculating transportation emissions. And where does this also come into play? When accounting for FERA emissions. So FERA emissions, what you need to know is that for the GLEC framework, all transport emission reported in scope 3 categories 4 and 9, if you follow GLEC guidance, you need to reflect full well-to-wake or well-to-wheel emissions. So you need to account for the entire life cycle of fuel production up until fuel consumption. However, we also have mobile consumption, combustion in scope 1, and we have purchased electricity or other forms of electricity to power vehicles in scope 2. Well, their fuel use is typically reported as tank-to-wheel emissions only, which means the well-to-tank emissions are not accounted for. That means that the well-to-tank emissions should be accounted for, but be reported under scope 3, category 3, fuel and energy related activities. This is very important because you otherwise won't calculate for the entire life cycle of emissions. This is where this concept is really important. It's also good to know that GLEC will always use well-to-wheel emissions as a guideline as a guidance to calculate transport emissions. Now, I explained the example of the transport chain. Here is an example how it looks like in practice for a single transportation route. So assume we are moving a good from Beijing, China to Nazareth, Flanders. Then it will consist of multiple legs, which are showcased here. It will be moved by truck to a seaport. Then it will take a sea journey up until the seaport in Ghent. And then it will take another road transport up until the factory, which is in Nazareth. Something I want to caveat here, which is really important. I mentioned in the beginning that we are accounting for hubs and warehouses. Today, for a lot of companies, this is not material because it's even difficult for logistics providers to calculate the energy in these warehouses accurately. So we are going to primarily focus on the transportation legs, the types and modes of transport being calculated. Towards the future, Climate Camp, but other tools and consultants will also try to incorporate these hubs and warehouses. But as of today, it is still very difficult. Now, how do we calculate up and downstream transportation? We try to use the same methods for transportation as we do for purchased goods and services or other corporate carbon footprint calculations, where we first start with defining the boundaries, which is material, which lanes, modes, legs, and hubs are included, where can we get data. And then we move into data collection, where we have different data points we collect depending on the type of calculation you do, which then leads to informing your stakeholders of what you need from them, logistics providers, internal stakeholders, and so on. Then we'll perform an analysis or a sanity check, as we call it, where we check that certain data gaps do not exist or persist. So wrong or missing individual values, large data gaps. So this can be corrected before we move into emission factor calculation and allocation, which you can do yourself via a tool or via a consultant. Finally, in the process, you will always validate your findings either with historical data points, which is why it is relevant to do calculations year over year so you can improve granularity and accuracy, but also so you have something to compare it to. But you can also try and compare it to competitors. And what we always recommend is having external validation to rubber stamp your results. Now, when we define, before we start calculating, it is important to define organizational boundary for the simple reason that suppose you have multiple entities, suppose you have multiple sites, then there's really important nuance as to internal transports moving from point A to point B, but it is still within the same organization. Or when we're talking about purchased goods coming from one entity within the group to another entity within the group. So it is really important for GHG calculations in general, but specifically also for transport, to really define what the organizational boundaries are. The activity boundaries, what generally is being calculated, or what I would say is the basis of transportation calculations, is that you calculate for goods, purchased goods from tier 1 suppliers to yourself, which is upstream, which I mentioned before. Finished goods to your customers, for which the reporting org pays, so you yourself pay for it, which is also upstream. And finished goods to customers for which the customer pays, which is downstream transportation. Now, there are a lot of special cases, and we're not going to deep dive into all of them. But as I mentioned before, distribution is not part of this webinar. A lot of companies lack access to information, for example, from retailers or from other chains in their value chain. So distribution is not part of this webinar. And the other special case I want to mention is account for empty returns if material for your business. If you have returnable or reusable goods and you're responsible for collecting them, then it is also important to account for empty returns. But we will not cover it in this webinar. Now, when we're talking about data collection, there are 3 levels of data granularity which you can apply: spend-based, weight distance-based, and fuel type-based. From left to right, they become more granular, but you need access to more specific information to perform these calculations. Now, for each of these calculations, you will need carrier name and information, product group and ID to link them to your purchased goods or your sold products, for example, organizational unit and reporting periods. This is the same for every type of calculation. But then you have spend-based calculation, for which you only need the amount of euros you spent on a certain freight shipment, as well as the mode or subtype, but this is optional. This would be a first rudimentary analysis or calculation, but what we prefer and what we always focus on is moving towards weight distance based. Here you will try to estimate the weight shipped, or maybe you already have access to the weight being shipped, and you will have the distance per leg. So we can calculate the ton kilometers, as mentioned before, for the transport chain elements. And then we will also track for mode and subtype. Again, you can go more granular depending on mode, can just be a generic truck, a generic train, and then you can dive deeper into subtypes, but you need access to this information, which logistics providers will not always be able to give you. Then the third one is fuel type based, where you then also know not only the type of truck and the subtype they are using, but also the fuel and energy quantity and type being used. Now, we don't generally support this because this is information that your logistics provider has. Fuel type based is something they can calculate much more easily because they know the types of trucks, they know the energy that was used, they have access to this information, but it is sometimes really hard for them to share it with companies, or they might not have access to it at all. So we always try to focus on weight distance based where possible. Now, after you defined which data points to collect, you need to analyze what you have received from your logistics providers or from internal stakeholders. We always do it on two levels. We do a macro analysis and we do a micro analysis. The macro analysis is, are there any major data gaps which are not present in the Excel or in any other data file? Therefore, you need to receive all the data and then create graphs with filters, for example, or use a tool to check which data entities are missing. For example, does all the purchased goods have transportation data linked to it? Are there certain goods which have not, if they don't have transportation distance linked to it, then there is something wrong. Are all transport legs accounted for? Are all org units accounted for? So this is a high-level macro analysis to see that no wrong exports happened or wrong imports happened. Once that is done, we move onto the missing fields or wrong values detection. If you are good with Excel, you can also try and do this in Excel, but this is primarily in tools that you can identify, are there wrong values? You would be surprised how many times commas, dots, kilograms, tons, metric tons, etc., how they get confused or how they can get corrupted during export or import. So it is really important to do a check on your data files. Are they formatted correctly? Do they have the wrong units? And are there missing data fields? Once you have completed these steps, you can move on to emission factor allocation. Now, when I was younger, I had a class on PowerPoint, and my teacher always said, never have more than 7 lines of text and this many words on the slides, where I now very much didn't listen to his advice. But this slide is primarily as information for you when I share the slides after the webinar. These are the important emission factor databases related to transportation and related to fuel combustion and transportation use. As you can see here, I've listed some global emission factor databases. GLEC is mentioned here, but IPCC, Ecotransit is mentioned as well. But especially for Europe, which I think most of the people here are part of, we also have some more specific emission factor databases like DEFRA or TREMOT, ALDEMI, or EcoInvent, which will also have some LCAs or factors for certain transportation types. Now, there are some common problems which I want to talk about. Like I said, there is a lot of nuance when talking about up and downstream transportation. What is material? What isn't material? Which data do you have access to? Also, this definition of what your organizational boundary is. So common things we often encounter with customers or with prospects is, for example, missing weights. We don't have access to weight information. There we always apply the same methods. We do an emission factor calculation based on spend-based emission factors. And then where shipments weights are available, we use that. But where there are no weights available, we check, okay, what is the transportation responsible, or what are the routes responsible for 80% of emissions, which are the products responsible for 80% of emissions, and then try to do weighing of these goods. Now, then we prioritize weighing of these goods to calculate for missing weights, but you cannot, obviously, if you're a large organization, start weighing everything. So you need to define for yourself what is feasible to do and which is a major impact on your emissions. The second common problem we often encounter is there is no view on where it goes downstream. Now, if there's no visibility on where products go downstream, you can make a reasonable assumption. For example, we have quite some customers who deliver to retail. You can then make an assumption on the distance a general consumer will travel between retail and itself, and then use the HQ, for example, to calculate the transportation distance. Because you might not know where the goods are transported to between distribution centers, where they eventually end up. You need to make reasonable assumptions to calculate for these emissions. Generally, we will not go further than tier 1 to tier 2 for suppliers as well as customers. Obviously, you can work with customers and suppliers to collect supplier-specific transport data. We always talk about using supplier-specific data because it can improve your calculations to a certain amounts, but you also need to work with your partners, suppliers, and customers to retrieve this data. The third one is internal transport. Now, you might often have trucks moving between sites, moving between relevant organizations within an organizational boundary. Well, here the best practice is if internal transport takes place off-site, so it uses public or private roads between two entities, then it is seen as Scope 3, Category 4 upstream freight transports. And if it occurs within the facility boundary, an example here is forklifts in a warehouse, or we even have companies that have transportation on site with trucks, for example, then it will be counted as Scope 1 mobile combustion or Scope 2 using purchased electricity, rather than transportation in Scope 3. These are some of the common problems when calculating Category 4 and 9. Now, I will hand the mic to my colleague Ruben, who will showcase a bit how we do this process in Climate Camp, and then afterwards we will move on to any questions you might have.
Thanks a lot, Maarten, for the in-depth introduction. If all goes well, I'll be sharing my screen now. Can you confirm if you see it, Maarten?
Yes, I can see it.
Great. So I would like to now show how these calculations are done in Climate Camp. Climate Camp is a software as a service that helps companies to calculate their corporate carbon footprints, product carbon footprints, and has a very strong focus on engaging collaboration among the value chain to achieve reduction targets, be them aligned with SBTi or independent targets. Today, of course, I'll be focusing on the calculation of upstream and downstream transportation emissions, which is mainly allocated in the calculate section. So as you see, I'll now focus here on the calculate section where it is possible to upload transportation activities. So once your boundaries are set, once you have gathered your data, you can upload this data into Climate Camp. This upload can happen both on a line-by-line item or using an Excel template. Usually we see with many of our customers that there is a very big data sets on transportation activities to be taken into account. Therefore, mainly the Excel upload template is preferred by most of our customers. But just to show you a bit of the fields that are required to do these calculations, I'll first demo this with a manual and data entry. So the first thing to do is to allocate the emission group and the organizational unit. Organizational unit is actually the unit to which an activity could be allocated. It is then possible to give the transportation activity a name, indicate the transportation mode, which is of course critical to do the calculation. And then it's possible to enter a from and a to date location. Maybe also what's also interesting or important to add, a lot of the data entry that is needed depends a bit on the data that you have available. As Maarten indicated, for some transportation activities, it's not always known where the start and the end location is, or it's not known how much the weight is that has been transported. So all these different scenarios are accommodated in the Climate Camp platform. In this example, let's assume that we know a start location. So it's possible to, for example, say, okay, we have a transport from Casserley, Belgium to Shanghai, China, which could be entered here. This is in this case, it's something that has been transported via a generic cargo ship. And then it's possible to also indicate the weight that has been transported during this activity. As you can see, it's also possible to indicate a supplier. That's a bit of the ICP or the unique selling point for ClimateCamp is that all activities can be linked to suppliers, allowing to understand the proportional impact of a specific supplier and also gather insights on potential reduction targets of the supplier or primary data that the supplier might be able to provide for the activities that they are performing for you. When this data has been saved and uploaded, actually our calculation engine will start calculating the emissions for that activity. I'll maybe quickly highlight how that also works using an Excel template. So as you can see, normally my Excel is now open. It's similar data points that can be added here, which is actually the name of the transportation activity, ideally the weight, but it can also be, for example, span-based data or ton kilometers data that could be uploaded, the organizational unit to which these activities could be allocated, a start and an end location, the reporting period for which the activity is available, and then the unit which is applicable for the activity. If this Excel has been set up correctly, it will be possible to upload that in ClimateCamp. So if you go back to ClimateCamp, you'll see that by using the 3 dots on the right side, you'll be able to upload import data, indicate the category for which you're uploading the activity. Here you'll be able to download the template and get a clear description on all the fields that are required. And if you click as a next step, you'll be able to then select the file from your computer. It will be mapped in the tables. If we click on the next step, you will see the first thing that we'll do is it will try to map the columns and the column headers with the headers that you have in ClimateCamp, because we sometimes see that the Excel files that we receive, let's say, for example, you have many different entities of which you're gathering data, or you're pulling this from different ERP systems. Maybe the names of the attributes are not always the same. If they're similar, as you can see here in the name description field, our AI functionalities will map this straight away to the right column where possible. In this case, all columns were matched, which is great. So as the next step, actually our system will validate if all the required data fields are provided for all activities. So I see that in this example, actually I have 2 rows which are missing required information. For example, the first line here, I see highlighted in red, it's missing the unit. So let's say that in this case, it was kilogram, which should fix the issue. And then we see that for the other one, actually the transport type was not indicated. So this one was by truck. And once entered, both columns are now, or all activities are now correctly filled in the Excel upload. And if I now click on import data, the data will be uploaded in the environment and will trigger the calculations for that activity. What happens then on the background is that actually we will start doing calculations. So this is a bit the calculation engine that is used behind the scenes of ClimateCamp. So let's say that we go from Casterlee, Belgium to Shanghai, China. We have, I see Frederick is joining. We have 10 tons being transported, and we know that it has done by sea. So we'll then calculate the emissions. And we'll then see the routes that are being allocated for each transportation leg. So in this case, we see that actually from Casterlee, Belgium, we still need to drive by truck to the port of Antwerp. We'll see here that is the first set of emissions visualized. We'll then have a cargo ship that is able to take a specific route. It seems that the bombing going on here does not impact the shipping route for this moment. And that at the end, then in China, there is still a final truck ride that will need to be done towards the city center of China. So we'll see we'll have 3 transportation legs here. First one by truck, then by sea, and then again by truck. So how does this then reflect in ClimateCamp? In ClimateCamp, you will see that for different activities, there are emissions being calculated. So if you look at a simple truck allocation, for example, this one transport glue, we will then go and look what is being done here behind the scenes. So we'll have a specific organizational unit allocated, a name for the activity. It has been transported by truck. We'll have a start location and an end location. This one went to Ghent and to Germany. Our automatic calculation engine will then calculate the distance between the 2 points. So in this case, between this point in Germany and Ghent is around 557 kilometers, which have been calculated. This is then the weight that has been transported. And then, of course, that's of course, if you want to see the emission factors or want to tweak them, because it's always possible to override the automatic allocation that has been done. So in this case, let's say that we know what we are doing. We will get the inside view on the specific emission factors, calculations for that activity. So in this case, we see that the emission factor of 0.160 kilograms CO2 per ton kilometers. So quickly reminder, what is a ton kilometer? A ton kilometer is translating the kilograms to tons and then multiplying it by the kilometers, which gets us the weight, how much weight has been transported over a distance. So in this case, ton kilometers that we take as emission factor. If we go and push on the question mark, we'll see the specific emission factor that has been used. We'll get some insights in this emission factor as well. And if we go here, we also get the emission factor source, so we'll get more insights on the specific emission factor source, which is in this case an emission factor from GLEC that has been used well to wheel, as Maarten just indicated, for a weight over distance, and a specific region that is taken into account as well. So that's a bit how these calculations are being done in ClimateCamp. Maybe to give a quick view on how this works with intermodal transport, meaning there is multiple modes of transport being used, which is the other example indicated here. You will see we will split this up into 3 transportation legs. It will be first a road, then a sea leg, and then again a road leg, where we then for each activity will understand, okay, the weight that has been transported, the weight that has been transported is the same, 396 kilograms. But of course, the emissions are different because there's different distances and different emission factors used. So if we would go for the first leg, we understand, and we see here, of course, they are all linked to each other in a specific transportation chain. We will see that actually this transport took place from the USA until a specific port in that region. That will be the distance that the truck has been done. So we'll see here that a specific emission factor for road freight has been used there. And we'll then see that for the transportation over sea, we'll see that in this case, it will be generic cargo ship, which will have then from that port to a specific port in Belgium, which has a different distance. And then, of course, has also a different emission factor as its sea transport. That's a bit how it goes. So bottom line, how it works in practice, usually we'll receive from our customers an Excel sheet with the from and the to locations and the weights, if those are and the mode of transportation. If those are not not available, then we usually will get spend data or ton kilometer data. We'll upload it in ClimateCamp, allocate emission factors for the spend-based and ton kilometer data, for the weights and the from to location with the mode of transport. We will then do a calculation of the distance, multiply to get to the ton kilometers per transportation leg, of course, and then allocate right emission factors for each transportation leg. So yeah, that gives a bit of a high level or a high level and detail also overview on how these calculations happen in ClimateCamp.
All right, thank you, Ruben, for this explanation. Now I'm going to quickly end with the final questions of this webinar. So I'll go here. So we have a Q&A section. I'm first going to focus on the question from, let me just pull it up for myself here. So Jelte asked 2 questions. The first or the second question, depending on how you look at it, how to handle cases where the intermediate transportation mode is not known, so in between 2 hubs. I'll let Ruben answer this, but my assumption would be that we always try to make the most reasonable guess between certain distances. If the distance is too long, there will always be we will always look towards sea or air or rail transport, but we will try to make an assumption based on the distance, what the most common used method is, also related to the weight. But maybe Ruben, you can clarify if there's other ways to look at this. You're still on mute.
Thanks a lot, Martin. Or as I was speaking to myself. No, it's as you indicated, if data is not, it often happens that data is not available for certain kind of activities. In those cases, it's most important to use assumptions to get actual or get high-level insights on what the emissions might be. What we see sometimes with customers is that they lose themselves a bit to go too much into detail, trying to get exactly the right data points which are needed to have a very accurate calculation happening. What we always recommend is to initially take a high-level assumption with the information that is available. If then based on that assumption, compared to the total corporate carbon footprint or total carbon footprint, we see that actually the emissions are material or actually have a significant impact on the total corporate carbon footprint, in those cases, we will usually dive deeper and try to make these assumptions more accurate by getting more granular data and more granular insights on these emissions. For example, what we very often see is that, for example, that our companies purchase products from a supplier, but don't have any insights on where these products are coming from and nor the weight that has been purchased. So in those cases, for example, we use assumptions based on the spend and then do an allocation based on what proportionate part could be allocated to the transport. So this is one of the examples. In this case, if it's in between hubs, if the information is not known, we always recommend to do certain assumptions. For example, if it's within a certain transport within a certain continent, we assume that the transport mode would be a truck. If then later on we see that proportional, it has a very big impact, then of course we would dig a bit deeper and try to get better insights and more accurate insights in these transportation modes, because also that would be then be later on a tool to allow to put up reduction plans, for example, to reduce these emissions.
Okay, thank you, Ruben. I'm going to go to the next question of Jelte, and then I'm going to move to the question of Jonas, which is also a very interesting question. But first, the question of Jelte, what's the difference between UK government transport emission factors and GLEC emission factors? Which would you prefer? Ruben, maybe you can take this.
I think Martin actually had also a slide about this. It was a slide with a lot of text. I think your teacher indicated also to reduce the number of text. So, but I get where the question is coming from. It's very important to indicate that there is a lot of different emission factors available. I think the UK Gov transport emission factors are definitely also very relevant emission factors. What we see is, or the reason why we use GLEC is the most internationally recognized emission factor database by Global Council that specifically on transport, where the UK Gov is maybe more Europe and UK focused. So it depends also a bit on where your value chain is allocated. It will be mainly in that region. It can be interesting to look at UK Gov as well. So here you can see actually there's quite a lot of emission factor databases which could be used. What we see now in the markets, and definitely when we want to compare with other organizations, is that GLEC is a very interesting and very focused on transport database that is used for transportation. UK government transport, definitely very relevant and good database. I think I see it here in the list as well. Under the Europe database is one of the top to use as well. But yeah, we see that the GLEC is more a global approach where value chains are very often globally, and it's rather something we prefer to use. But it depends also on the value chain that you have and the specific regions where you're active in.
Okay. Thank you, Ruben. And maybe we can move on to the question from Jonas. Would you take the most conservative estimate if it is unclear? He had a theoretical case of transport from Israel to mid-Germany, which can be done by truck, train, or a mix of transportation modes. But nobody could say for certain, and my transport expert said it would depend daily on what is feasible. Well, this is a good example of not always having the right transport information available to us, even logistics providers, as it can differ from day to day. So, Ruben, would you take the most conservative estimate if it is unclear or not?
Yeah, so my approach would always be to go for the most conservative. Definitely in the world of greenwashing, it's better to overestimate than underestimate. That's usually what I indicate. But yeah, again, it really depends. I think I would start from a conservative approach, indicate what the emissions are in that scenario, and then if you see that the emissions are material, and definitely when you want to work on these emissions, I think that's the moment then to dive deeper in these carbon footprints and these transportation modes.
All right. Thank you, Ruben. And then maybe a final question from Dane, but it might be that we need to come back to you at a later point. But his question is, would you use DEFRA EF factors for activity data based in the Netherlands, or would you use RIVM, NER, or would you use EcoInvents? And also to just quickly mention, everybody will get a copy of the slides after the session. That's why I created the slides with emission factor databases, so you can consult it later. But they needs to align with 14,064 reporting, and that is why his question from the emission factor databases comes from.
Again, there is many different databases. I think in this case, activity is based in the Netherlands, so it's a specific use case. To be honest, I'm not familiar with all the local requirements, so I'll be happy to get back on that via mail afterwards. Again, I'm not familiar with every specific database in every region and what will be the most applicable there, but it's definitely something we can follow up on via mail, Dane. So you'll get a message from us afterwards to get a better insights on that specific question in the Netherlands.
All right. Thank you, Ruben, and Dane will couple back with you afterwards. Everybody else would certainly get the slides of this webinar. Now, to close it out, I want to quickly mention what we are going to talk about in the coming weeks and months. Two main topics, two very relevant topics to carbon mature companies. One being how you can secure preferred supplier status by calculating product carbon footprints for your relevant products or all your products, which I will be joined by Ruben and myself on Tuesday, the 28th of October. And then a second one is how we are going to reach our Scope 3 reduction targets. You have made a commitment, you have set SBTI, now you need to achieve your goals. How are you going to do that? We're going to dive a bit deeper into this topic. I have an SBTI specialist joining me, which I will announce later. You will be able to register for these webinars in the slides or in the mail that